So ozone layer, which is a layer in the stratosphere that consists of O3, protects us and shields us from ultraviolet rays. Consider it the sunblock that our Earth provides for us in the atmosphere. We have caused a big problem in our ozone layer, causing a hole due to gases that we emitted back in the 80s. Remember also that ozone in the troposphere is bad. It is linked to photochemical smog. So the number one ozone depleting compound is chlorofluorocarbons. This is the compound we're going to focus on because it is what mainly you need to know. You also need to know the halons and HBFC or hydrofluorocarbons are also linked to the ozone hole or the depletion of ozone in our stratosphere. What produces CFCs? Coolants or refrigerators were a big contributor to CFC emissions. Basically, any air conditioner, your car, your home, or refrigerators had CFCs. Aerosol spray cans, big topic. In about 89, I can clearly remember, they were going to ban aerosol spray cans because of the concern of the CFCs. They did find a way to continue to have aerosol cans without CFCs, so they didn't have to ban them altogether. What they did was ban the CFCs. They basically now show a little symbol that says ozone friendly or CFC friendly. Solvents and foams are also linked to CFC emissions. And what's interesting is that CFCs were banned altogether in the United States. The Montreal Protocol banned CFCs. So you need to link this word to the banning of this compound. In 89, when they first observed or first took into consideration this big severe problem of the hole in the ozone, you could see what happened after 1994. Emissions were completely eliminated. So how does this happen? Well, CFCs are compounds that make it all the way from the troposphere to the stratosphere and nothing breaks it apart. It, as I said here, and I forgot to mention, it can stay in the atmosphere for up to 65 to 385 years because nothing really reacts with it. So the only thing that breaks it apart is ultraviolet radiation. UV rays, ironically, they strike this molecule and emit a chlorine to break away from this molecule. You don't have to worry about this compound that's left over. We're just going to focus on the chlorine. So as you see here, let's say this is the second part of the reaction. Chlorine collides with an ozone. So basically, with this collision, it's going to steal an oxygen atom away from ozone, leaving oxygen gas and forming chlorine monoxide. This is where we're going to focus on for the part 3 of the reaction. You have chlorine monoxide, which collides with, let's say, a free-floating oxygen, and it's going to produce oxygen gas and another free-floating chlorine. The sad thing is that this chlorine is going to go back over here and start this process all over again. So one CFC molecule can lead to 100,000 ozone the depletion of 100,000 ozone molecule because this continuous process. So again, you're going to start with a CFC molecule, UV rays hit it, they break apart a chlorine. This chlorine reacts with ozone, producing chlorine monoxide and an oxygen gas. Chlorine monoxide will react with a free-floating oxygen in the stratosphere, producing oxygen gas and leaving another chlorine to go back here and continue to damage ozone or break apart ozone. So some other facts you need to know. Stratospheric clouds accelerate this reaction. So clouds in the stratosphere will accelerate this reaction. And CFC is toxic corrosive, has odor, and is flammable. This is a video I'm going to show you in class, a little bit of history of the ozone hole. Here's some more images of the reaction or other diagrams you can use to interpret. This is a graph of the total levels of ozone between 1970 and 2010. And as you can see, we have a slight increase. I'm going to show you this video also in class. Here's a diagram of the hole in the ozone over the years. This particular graph, I'm going to ask you to interpret in class with me.